Welcome again to Chemistry 1407, Lab 6, Qualitative Synthesis of Aspirin. So, why is this lab qualitative, not quantitative? Quantitative deals with specific amounts. Well, qualitative labs, it's important to have all the chemical substances present, but not in a specific amount. Then, talking about aspirin.
Okay, so aspirin's active ingredient is acetylsalicylic acid. Many years ago, people used to actually take the bark from the willow tree and chew that to get the active ingredient. And so we actually have some of the bark, and this is actually packed in your lab kit. What you're not gonna do is take this bark out and chew it.
No.
No. This is provided for you to figure out and to test and see what part of the aspirin is in this willow bark. The other thing they used to do is also take, if they're a middle class cave people, they would take the willow bark and put it in here and have some tea.
Please don't do this
We will
at
not
all.
do that one either. So we have moved on from the willow bark. Now we have aspirin in this form, in the pill form. Okay, so you want to use the pill if you have a headache versus chewing the bark that was provided in your kit.
Exactly.
So as far as the experiment is concerned, you're going to be working on.
So here the active ingredient is acetylsalicylic acid. So the reactants will be ethanol, acetic acid, and to actually test the active ingredient, has it been produced or not, we're going to use a reagent, iron chloride. And we have here the salicylic acid, acetylsalicylic acid. Also to do the qualitative tests, we have pH strips, we have well plate, and droppers. Droppers that we marked so that we don't contaminate when we take the chemical substances. So these are all the things that are included. All of it are provided in the kit.
So the one thing I'd like to mention is the warning. Please make sure you read the warning on this. Even though acetylsalicylic acid is an active ingredient in aspirin, please note that there is a warning that comes with it. It does have a lot of side effects. Keep this away from children, pets, little fifi, keep this away from them.
Exactly. So let's do the experiment. Okay, so synthesizing the aspirin. So the process uses a reaction that is esterification reaction, where the functional group of an alcohol, a hydrogen of the functional group of the alcohol, reacts with the OH from the carboxylic part of the acid. And then the OH and the H reacts, giving off water. Where the H and OH breaks off, the rest combines and produces the ester. So following this esterification reaction, producing the active ingredient of the aspirin, the reactant salicylic acid is a special substance where it has both the carboxylic acid group and the alcohol group. It doesn't react in between them. Instead, the hydrogen from the alcohol, same way, reacts with the OH of the carboxylic group of an acetic acid, giving off water. And where it gets cut off, the rest combines and produces the acetylsalicylic acid. This is an ester. How can we tell? Because of the carbon, oxygen, the cocoa bond, we can say, with an R group. So this is the ester part of it. And this is the active ingredient of aspirin.
In the aspirin, you have acetylsalicylic acid. If you have very old aspirin, what happens is this reagent here will react with water, and this reaction is actually reversible. So it reacts with water and it begins to break down to form the vinegar or acetic acid smell, the vinegar smell or acetic acid smell, and you'll begin to smell this in an old bottle of aspirin. So if you smell that, what will happen is if you take it, it will irritate your stomach. So it might be time for you to go and buy a new bottle.
Exactly. So this is the synthesis of the active ingredient of the aspirin, acetylsalicylic acid. So add the chemical reagents according to mentioned in the lab. We have here the well plate, which I have labeled just like as it is presented on the lab, and I have labeled the pipettes, one for ethanol, one for iron chloride, one for acetic acid. So what I'm gonna do now is that take all of the reagents one by one and add it one by one into the well.
So we are on page 7, working on number 2. You're transferring 10 drops of ethyl alcohol or ethanol from B1 to A1.
10 drops, right?
Right. Make sure you're using a white colored base or use the paper so you can see the color change.
Next would be
Okay.
stirring this.
Okay, our stirring rod is so skinny. There it is in my cup. Very skinny. Oh wow, you have the pH paper. Look at that. Okay. I'm touching the end of the glass stirring rod onto the piece of pH paper to test for the salicylic acid solution. And once we test it, you will write your observations in your lab report.
So
data
make
table.
sure to stir well the salicylic acid and the ethanol for them to react, and they need to mix up well, and then let's use this end, put it on the pH paper to see color change.
Okay. So you will find your color change when you do your experiment.
Mm-hmm.
Okay.
So that's how you continue to do the experiment.
So the
And
next
collect all
part,
the data and put it on the data table.
the next part then essentially has us transferring 10 drops of the ethanol from well B2 to A2. So we have shown you how to do the lab, how to test the pH, and how to mix the solutions. So follow the rest of the procedure in the lab, and then make sure that you write your observations in the data table that's provided for you in the lab. Thank you.
Thank you.